Hello everyone, welcome to the Unit 8 videos. So this will be our first video. They're going to go through the task pretty fast. We'll kind of do it the same way we do in class. I'll give you some time to think about it with your groups, then we'll come back, we'll do it together. What's a little different is we're going to probably hit on every question as opposed to just some of the questions. May or may not hit every single one, but we'll probably hit pretty close to all of them. So let's get started. The performances at Podunk High School drill team are very popular during halftime at the school's football and basketball games. When the Podunk High School drill team choreographs the dance moves that they will do on the football field, they lay out their positions on the grid like the one below. In one of their dances, they plan to make patterns holding long, wide ribbons that will span from one dancer in the middle to 6 other dancers. On the grid, their pattern looks like this. So you can imagine, with the third eye, kind of like, oh, pretty, yay, okay. The question that the dancers have is how long to make the ribbons. Gabriella G is standing in the center, and some of the dancers think that the ribbon from Gabriella to Courtney will be shorter than the one from Gabriella to Brittany. So, number 1 and 2, ask how long does each ribbon need to be, and explain how you found the length of each ribbon. So now go ahead with your team. So you think up some ideas. How can you figure out Gabriella to Brittany and Gabriella to Courtney? I'm just going to be about 10 seconds in the video pause, but go ahead and pause the video and then take about 5 minutes, no more than 5 minutes, then come back and we'll do them together. Cool. Alright, so if you didn't have enough time to pause, make sure you do pause, make sure you get that time to do it together, but let's take a look at it. So, if we apply, there's probably a couple different ideas floating around, but if we apply a slope idea, since we have kind of a little mini linear line here, right, we can apply a slope idea or a triangle idea. If we were to make a triangle, maybe this way, from Gabriella to Brittany, we could see that that triangle would be a right triangle, and we know some things about a right triangle. We know that for a right triangle, a squared plus b squared equals, class, yep, c squared. Pardon me. Technically, in the triangle, it's just a, b, and c. Oh no. Okay, heads up, I am working on my phone, so it is tiny over here. But anyway, we know a squared plus b squared equals c squared. So if we need c squared, because on our triangle we can see it's kind of lopsided, we have a, b, and c, I need to find c. Well, c is diagonal. I can't find the length of something diagonal. I don't know how far across a box is, right? So I'm going to use the Pythagorean theorem. I know a and b. It looks, in this case, a is 5. Yeah, sorry. The triangle should have gone to here. There we are. The cross would be 1, 2, 3, nope, 4. Yep, 4. Don't know why there's a little 5 there. That's weird. Oh, it's a B. I'm sorry. Okay, so that's a 5, 4. And then up here is 4. So each one is 4. That's a nice, cute little coincidence. We have A is 4 and B is 4. So 4 squared plus 4 squared. Careful, that is not 16. Okay, we know that it's not going to be 16, it's not going to be 8 squared, right? We got to follow the rule of PEMDAS, that's c squared. But pretty easy to solve after that. It is 16 plus 16, so we get this 32.
Teachers, there will be.
Okay, so we see that 4 squared is 16, 4 squared is 16, so we get that 32 is c squared. And we have to be careful. That doesn't mean we have 32 length here, right? It means we have c squared is 32, so we have to square root both sides now, and we get 32. Or square root of 32, pardon me. Now, since we are dealing in the real world, right, we don't really walk around, you don't see a lot of contractors saying, oh yeah, this board is square root of 32 meters long. Like, you don't really see that a lot. We can go ahead and actually plug that in a calculator. We know it's going to be somewhere between 25, which would be 5, and the 36, which would be 6, right? More leaning towards 6. And if you do plug it in the calculator, C would be equal to 5.7-ish. We'll use about 5.7. Since it doesn't tell us what kind of unit system is happening here, we can say units. All right, cool. So that's one way we can do it. Now we can go ahead and double check that against Gabriella and Courtney. Do we get the same thing? So we'll do that one in a different color. Same idea though. We can draw another little equilateral triangle. Now you may even visually be able to see this, right? We can see they're kind of the same triangle. So we can say, oops, they are both 4 as well. And for Gabriella and Brittany, we say a squared plus b squared. Sorry, Gabriella and Courtney. Repeat, repeat, repeat work. We're just going to get exactly the same thing. And we see that C is also about 5.7 units. Alright, and so we indeed see that they are actually the same, and the dancers have nothing to be worried about. If they pick up the wrong ribbon, it's going to be okay. Alright, moving right along. Please make sure you filled out, explain how you found each. Basically, you could say, using Pythagorean theorem. If you did it a different way, that's okay. But if you had no way, this is a good one. Pythagorean theorem. Alright. Scenario number 2. Oh no. Okay. Scenario number 2. When they have finished with their ribbons in this position, they are considering using them to form a pattern like this. Okay, so it looks like... What happened? Everybody connected the ends. Okay. Will the ribbons in the previous pattern be long enough to use to go between Brittany and Courtney in the new pattern? Explain your answer. So Brittany and Courtney now. No longer Gabby to Brittany, Gabby to Courtney. We're talking Brittany to Courtney. So this line here. Okay. Well, we could do the same thing, right? We can do the same thing. We just need to draw a right triangle, figure out how long. So we'll have to find a right triangle. Not going to be a nice clean axis triangle. Doesn't mean we can't do it. If I draw down this way, over there, still see my right triangle. So again, take about, not even 5 minutes this time. Let's just do like 30 seconds, maybe a minute, however long you need to kind of get this answer. But don't take more than a little while. Go ahead and find the length of this quote-unquote C, or in other words, the length of Brittany to Courtney. Alright, cool. Now, let's go ahead and do that together, just in case. If you did do it on your own, remember you should be pausing the video. I didn't clearly give you any time. I did not give you a minute. But pause the video if you need more time. If you didn't, though, if you are all finished, you find that that length is about 4.5 units. Now, how do we do that? We would have this triangle here. We can see it still goes up 4. But then now it only goes 2 across instead of the full 4 across, right? Brittany and Courtney are not as far away as they are from Gabby. Yes, that is half. That's not really kind of the pattern we're going for here. Maybe that's something about this pattern particularly, but we could have used a different triangle, one on the other side. Anyway, so fill that in. Oh, pardon me. 4 squared plus 2 squared equals c squared. We end up getting 16 plus 4 is 20. That is equal to c squared. You take the square root of that. Like pretty much right in between 16 and 25. So yeah, about 4.5 units. Cool. Alright, if there's any questions, make sure you ask. Kind of hold your questions till the end, just so you can get through the video. I've had past years that I've been out where the video doesn't get completed because of questions, which I think is great. Questions are awesome. But kind of hold them till the end. If you have any questions, write them down. And that way you can ask the sub, you can watch the video again, you can ask each other, you can check out the key. Yeah, just like hold on to them for now. Okay, so next scenario we got. Gabriella notices the calculation she is making for the length of the ribbons reminds her of math class. She says to the group, hey, I wonder if there's a process we could use like this, or we could use like what we've been doing to find the distance between any 2 points on the grid. She decides to think about it like this. I'm going to start with 2 points and draw a line between them and represent the distance that I'm looking for. Since the 2 points could be anywhere, I'm going to name them A and B, also known as x1, y1, and x2, y2. When I figure the length of the ribbons, what can I do next? Okay, so what can she do next? I really, really like the way Gabriella's thinking about this. Thinking about the process you use to find the length of the ribbon, write down your steps here in terms of x1, y1, and x2, y2. So we're on the next page now. Go ahead and see if you can mimic this process for any 2 points, for things you don't know about. And again, take about 5 minutes with your group to go ahead and do that. You can pause the video, come back in just like 5 minutes though. Alright, so hopefully you had a chance to pause the video. If not, please make sure you do. If we kind of use this line up, this grid up here, what we can see is we can still draw that triangle, right? And what we get is not a defined number, right? You have to be careful. The graph that we have here is not, we're not stating that these points are actually 4 up and 6 over, right? That's just, you know, that's just ambiguous, like, here's a grid, here's an idea, roll with it. So you have to be careful. This is not actually 6 over. Instead, what it is if we look at these distances, well, this would be on a graph, whatever graph we had, x1, and this is x2. So while this distance very literally would be 6, but any distance could be represented as, hopefully you saw, x2 minus x1. Or I'm going to be honest with you, x1 minus x2. It doesn't really matter. Because in Pythagorean theorem, what do? We square that. So it really didn't matter which way. Distances are always positive. So maybe we'll shoot for the positive way, right? Over here, same idea. We have y2 up here, whatever y value this is, down to y1. And remember, this notation that Gabrielle is using is the same one for slope formula. This is the second y, the first y. It's not some new fancy subscript notation. It's just y's. And so once again, I know it's not literally 4. That's just what the picture is telling me. But the way I would find it is I would say, okay, if y1 or if y2 excuse me, if y2 was like 6 and y1 was 2, well then it's clear that there are 4 in between them because of 6 minus 2. So y2 minus y1. These expressions sound a little familiar. They sound a little slopey, right? Isn't this how we find the slope? Hopefully, maybe you saw that, maybe you didn't, but this is also how we find the slope. We count over and we count up. Same ideas. We did the same idea to find the distance. We just used it in a different way. So we have these 2 expressions now. What did we do with them? We called this one A, we called this one B, we called this one C, right? And we said, okay, A squared plus B squared equals C squared, right? Well, now I don't know 4 or 4 and 2. I know x2 minus x1 was A. And I know that y2 minus y1 was B. And then I would get C squared. Now that's great, but that's still kind of 2 steps, right? Like, that's not really a formula, right? So this may have been where you got. This is a process. I would then take that, whatever answer I got, what would be the last step? It would be to square root it. So we could say C would now be the square root of both sides, and while that is really ugly on the other side, we finally get C. We're kind of going back to those literal equations, kind of solving for C here. I'm just copying and pasting everything we had before that we then square rooted. And this thing is actually, ironically, called D. Not really because it's a fourth side of the triangle, which makes no sense, but it's the distance formula. This is the distance formula. It's a formula for distance. It's a formula for distance, and we usually label it D. Cool. If you managed to get that, give yourself a good pat on the back, because that's really kind of a long, complicated process. If you got to the second to last step, also give yourself a pat on the back. It's pretty good, pretty good. But go ahead and give that a nice box, regardless of whether you gave yourself a pat on the back, because that is really the key focus of the first part of this chapter, is we want to be able to find distance, and we don't want to have to draw a triangle every single time. Alright, cool. Number 5. Use the process you came up with in number 4 to define the distance between 2 points located far enough away from each other that using your formula, number 4, is more efficient than graphing and counting. For example, find the distance between negative 1125 and 2316. Use the process to find, oh, sorry, that's 6 is a totally separate problem. So let's go ahead, I'm going to have you guys try it out real fast, like a minute. take these 2 points, do the ones they suggest, take the example, and then find the distance using not the triangle, not graphing, because let's be honest, that takes forever. Use the distance formula. Alright, cool. So, again, you should have paused the video to do this. If you didn't, please make sure you do so. Let's go ahead and set this up. So if I look at this, this is x1, y1, x2, y2. Just like with slope, you want to be careful. You don't accidentally call one of them both x and one of them both y, because that's what you're aiming for, right? We can see in our formula we want to put the x's together, we want to put the y's together, but we don't want to assign it that way. And that's what I see people do a lot, is they're just like, oh, these ones are the x's, those are the y's, okay, let's go. But that's not what's happening, right? We know that in a point, x comma y is try that again. X comma y is what we always have. It's not an x and a y situation, right? It's one of each. So we'll go ahead and now that, oh, pardon me. Like I said, my phone. We'll go ahead and plug those in now that we have this convenient formula. This is kind of how I do it. I make the bones of the formula, because let's be honest, it's not as pretty as a squared plus b squared equals c squared. But, you know. So I make the bones, and then I go back and find the numbers. So x2 and x1, 23 minus negative 11. Oh my goodness. And then remember, technically, since we're squaring it, we could do either negative 11 minus 23 or 23 minus negative 11, because either way it'll be the same thing. What we don't want to do is 23 minus 11. Right, because 23 minus 11 would not be enough distance. We want to make sure we go all the way over to negative 11. So watch out for that. And then the y's were 16 minus 25. Okay. We do that, and we get 34 squared plus negative 41 squared. Oh, no. Did I drop a negative? I did. Negative 16. Pardon me. Negative 16. We get negative 41 squared. Yeah, again, I'm on my phone, so I really apologize for the horrible handwriting, because I have a standard, like little iPhone 7, not the Plus version. It's tiny. Anyway, so we'll go over here. Square root of all of that. We would do the squares first. So we get 32 squared. I'm sorry, 34 squared, which is 1156. Notice the positivity. And then negative 41 squared, which we know will be the same thing as positive 41 squared. And we get the square root of 2837, which is about, pardon me, calculator is not working with me. Yep, about 53. We'll take it to like 2 decimal places, 53.26. One could argue that since the points are in whole numbers, you could even round to 53. We want to say it's not exactly 53, right? So 1 or 2 is fine. But we want to make sure we slap on units. Cool. Now that was a lot faster and a lot less room than having to graph both these points and counting, right? Same thing with slope, right? The slope formula is faster than counting the slope on a graph. They are virtually derived the same thing, but it is faster. Okay. All right, number 6. Use your process to find the perimeter of a hexagon pattern shown in number 3. So the perimeter of the hexagon pattern. This one I'm going to give you a chunk of time to do because I'm not going to do the whole thing together. But the one in number 3 is right here. We found BC. Woot! It's 4.5. Does it mean I need to now find the insides or the outsides? Well, if you recall, perimeter is the outsides, right? So we need to find the distance going around the whole thing. Luckily, there may be some facts you know about this hexagon. This doesn't look like, you could double check, but this regular hexagon, I don't think it's regular. Sorry, I take that back. But some things may have equal length of some kind. That's just a hint, though. You don't necessarily have to do it. You do have a distance formula, so go ahead and find the distance all the way around. Take your time, work together. This is the last one of the day. As soon as you're done, then unpause the video. I'll show you the answer, and you guys can start your homework. Alright, so hopefully you've had some time. Together, all of these together, you end up getting 30 feet. Woo, 30 feet around. So that's a big hexagon these dancers want to make. Double check your work and everything. It should all add up to about 30 feet. You can see, like this guy, who is also 2, 4, would also be 4.5. Same dealio here. Some symmetries there. This last guy, unfortunately, he's 3, 4, so you do some more math calculation. You're going to get the other two, and you would get a total of 30 feet. All right. So at this time, start the homework. I believe you should have some time. Ask any questions you have of the sub or each other. Check the key. And then I'll see you for 8.2.